good and you're keeping up well. Okay, so we are having a session today, software design patterns with Ifeoluwa. Ife joined later, but I dropped a link in the channel earlier today and also this evening. That's because we are gathering a lot of information to like help with the next set of build up applicants and all of that. We're already starting to like put more structures to build up. So build up, and now I've tried to explain this thing to people that have joined the other sessions before now. Build up will no longer just be a platform where a one-off thing or a community initiative. We're trying to like make it an institution. Yes, trying to make build up like an institution on that build up plan where people can now take courses and take resources, learn a tech skill for a period of time, right? And at the end, you can now build projects and even get a laptop in the end. So it's not just come and apply, do aptitude test and get a laptop, but this way it's more you get to learn in the process. And you know that someone was asking me last time, is this not the same thing as Enyata Academy? No, it's not the same thing as Enyata Academy. Enyata Academy is that you get trained and you get to work at Enyata. But the thing with Enyata Academy, it also has this short point because Enyata Academy tends to train just a very limited amount of people, right? 3,000 people can apply and just 10 people will make it into Enyata Academy. Well, but we build up land, we are expanding the threshold, expanding the capacity to accommodate more learners and just to like support your tech career growth, to accommodate more learners to like learn, you know, land, it's more going to be more intense, more rigorous, and the results will come out better than any other tech trainings that you've gone to or been to before, right? But we cannot do all of this without your input and your help because basically this training is going to be for you, the community members, right? So we need your help as much as possible to like help us tailor this coding school or institution. So the survey which I dropped earlier was for you to like fill it, drop your thoughts on what you think is the right way, that what you think, what you want to see in build up plan, what you want to the trainings, sometimes during build up some people will be like, oh, they don't accept my track. You need to write it in the survey so that everything is well structured and put into place and people now know that, oh, this is what you want to get out of this program, and so that we don't waste your time by launching a program that does not really benefit you. So when I'm going to drop the link again tomorrow morning, I guess. Please do well to like fill it up. Also, we want to meet with one of some of you one by one. I think we have Ezekiel in this call, we have Tolulokwe in this call, we have Nafiu Taiwo. So if you want to talk to me one to one with your thoughts, you want to have an interview with me and tell me, oh, this is how I want this thing to run. Oh, this is how I want this training to benefit me. Oh, this is the inputs I have that will benefit the product team that is working on it. Please reach out via DMs and I can schedule a call with you. I even have a Calendly link that you just fill up my Calendly link and book a call and let's talk about your opinions. So your opinions count. Your whatever it is that you're bringing to the table concerning build up plan and how you want it to be structured, it counts, it matters. And that's why we're like putting in so much attention to make sure that we are getting all the information that we need from you guys and being able to like provide you guys with the right value for build up learn. We don't just want it to be those tech trainings where you just come and learn and you don't get any value from. That at Enyata, it's always quality over quantity for us. We want people to be very trained. That's why we can do very small thing and the result is, better than when we do maybe something bigger and it doesn't come out well. So bear in mind that you'll be getting the best instructors, the best mentors, best tasks to do, and you come out a better software engineer, a better product designer, or whatever it is, right? Without further ado, do you guys have any questions, anything you want to say before we like go into today's session properly and try to get more people to like join in since they don't know that we've started already? Anybody that wants to say anything? Taiwo, Ezekiel, Tolulope.
Nothing from my end.
All right, Ezekiel. All right. So if there is nothing from your end, I would just like to start today's session. Today we are speaking to a developer here at Enyata, and her name is Ifeoluwa. Sorry, Ifeoluwa. I actually see her as a nerd. Like she looks so smart when coding, when doing the things that she's doing, and she's just like a great person to like learn from. So today she'll be joining us today to discuss software design patterns. So you could just relax and get to learn from the boss because she's actually the boss. Why I try to get more people to join it. Hi Ife, how are you?
Hi,
Hello. Ife.
Precious. Yeah,
Yeah,
I'm good. How you doing?
we are good. Can go ahead and introduce yourself.
Okay.
You're muted though, in case you think you're speaking to. Okay.
Yeah. Hello, everyone. Don't know. Can we signify if you can hear me? Audible.
Yes, we can hear you. You
Okay.
are audible.
Okay. It's so exciting actually to be here to talk about one of my favorite topic in software engineering, which is design patterns. But before I go on, I'd like to give a brief introduction about myself. Pardon the picture, I'm not really photogenic. Anyways, my name is Ifeoluwa. I'm a software engineer with over 4 years experience. I would love to call myself a DSA expert, but fear they catch me. But I'll just say I'm quite good with DSA, data structures and algorithm. My 4 years journey started with Java, and then I picked up JavaScript along the way. Um, I'm also one of the TikToker. So these are the workshop outline. These are the workshop outline. We'll just be rushing through design patterns generally, the usage, the types. It's also coding examples, and then finally the QA session. So before I start explaining, I would like to throw a general question. To answer this, what are design patterns? I'm pretty sure we have like senior engineers in the house that could attempt to give an answer to this. Can you please unmute your mic and
Mute your
attempt?
mic or just type. Anyone. Thank
I'm
you.
already unmute your mic and talk. Anyone? Okay, and I'll just go ahead to explain it then, since no one is volunteering. Um, Let me give an instance. So let's think of design patterns as recipes for solving common problems. When you're trying to build some like a software or physical object. So just like recipe in a restaurant or when you're preparing food makes your food tasty and delicious. That's the way software design pattern gives you a set of tried and true steps to solve a specific kind of problem in an efficient way. So let me try to break it down again. Imagine you're an architect and you're trying to build a house, and you notice that, oh my god, this house that I'm trying to build has a lot of windows. So instead of figuring out how to build window from the scratch every single time, you create a standard plan for making windows. So this plan can include, materials needed, the shape, and structure and how exactly it fits into the world. So that's design patterns for windows. Or imagine as a lady you're trying to sew a dress, or generally you're trying to sew a dress, and then you realize that this dress has a lot of similar designs. So instead of at every point in time they are trying to make that particular design, you're now starting from scratch. You create a standard plan for making the design, thereby reducing the time that you're going to spend replicating design every single time. And you're also creating a standard plan for actually creating the designs. So similarly in software development, there are like common challenges that come up again and again and again, like how to organize your code properly, how to write clean code, how to communicate between different parts of the program, or even how to handle exceptions or errors. So design patterns actually provide solutions to this kind of challenges, making it easier for developers to create reliable and maintainable software. So let's see it like this again, breaking it down again. Let's see design patterns as blueprints or templates that help you build things in a smart and consistent way based on like experience of software engineers that software engineers have encountered this particular problem before. So you don't have to go through the same stress that they went through when they encountered the problem. That's what design patterns are. So in between the explanations, I'm just going to be asking for people to drop messages on the chat to ensure that I'm not just talking to myself and you're actually understanding and following what I'm saying. So I don't know if you can maybe drop a thumbs up or messages. Oh my god, I didn't see this to look like. Design patterns are designed to common problems in software design. This is actually a very nice explanation. I knew that we had senior engineers in the call. I mean, Tolulope is one. It's a nice explanation too. Um, okay, just going to be proceeding to the next slide. Yeah, we know about the Gang of Four, the GOF. That's the abbreviation. Does anybody knows about the Gang of Four? You could also like drop messages in the chat box. Anyone wants to attempt? Tolu, you could also drop an attempt too. Okay, I'm just going to answer it then. Um, so basically, the Gang of Four are Eric, if that's the right pronunciation, Richard, Ralph, and John. So these four brothers, I like to call them brothers, in 1994, they developed or they published a book called Design Patterns. That's element of reusable object-oriented software. Yeah. So this book basically what it contained was solutions that were obtained by trial and error by numerous software developers over a period of time. So let's say, I mean, uh, early 90s, right? Software engineers then obviously faced problems that I'm currently facing right now in development. So instead of me having to experience it again, they decided to create a book where they imputed all the solutions to common errors, common issues that could come up when developing a program or software, basically. So um, that's where design patterns actually originated from the book Design Patterns by these four brothers. So this actually like initiated the concept of design patterns in software development that we are currently making use of. In the book, the authors I think they pointed out about 23 design patterns generally that they addressed. But in this workshop, we're going to be touching on just four of them, um, rushing through them basically. So let's quickly look at the usage of design patterns. First one is common platform for developers. What do I mean by common platform for developers? I think before I go on, I actually need to see messages or thumbs up on the call to actually ensure that people are listening. I don't know. Yeah, thank you. Thank you for the thumbs up. Thank you. Okay, let's move on. So common platform for developers. Uh, so I want to give an instance. Generally, design patterns serve like as a common platform for developers by providing a shared vocabulary. When I mean vocabulary, I mean like languages, best practices, reusable solutions to common problems that we could encounter while building software applications. For example, design patterns establish a common language that developers can use to communicate, design, discuss software design concepts. For example, now I'm on this call. Imagine I start communicating in Igbo language, and I'm sure that a percentage of people on this call can't speak Igbo. So that's the way design pattern is. So me speaking Igbo on this call disrupts the communication. You won't be able to understand what I'm saying. You won't be able to get the necessary knowledge you're supposed to get from this call. So that's the way design pattern actually acts. Design patterns, because it creates like this shared vocabulary and language, it improves communication and collaboration between team members. Another advantage or uses of design pattern is best practices. So looking at all my explanation and why exactly the four brothers brought up the whole idea of design patterns was to avoid, always rewriting the same code. Imagine I encountered an issue while developing a software application, and someone else, maybe Tolu, is building an application, and he also encounters the same system. The same way there are like different routes to the market, we could have different solutions to actually solving that particular problem. One might be efficient, one might not. So to actually enable implementing best practices while we encounter issues or while we're building software application is one of the reasons or usage of design patterns. So like I mentioned initially, there are generally 23 design patterns, but we'll just be covering four of them in this call. Um, the first one we're going to talk about is the single team pattern. I think this is like one of the basic design pattern that we have. But let me try to break it down again. Imagine you're in a special room, or you have like this particular room in your house or in your apartment, right? And that room you keep very important stuff, maybe your maybe gold self, or a lot of money or your certificate, basically important stuff. And this room has just one rule, sorry, that only one person can enter at the particular time. So that way, you know that you always know where your important things are, and you don't like accidentally lose them or create duplicates. Like you're able to keep track of who exactly is coming into the room, and you can see when the person is going out to ensure that the person is not taking anything out. That's in the real world sense, right? But in the world of software, the single team pattern is like this special room, right? It ensures that there's only one instance. When I say instance, I mean one copy, right? One copy of a particular class in your program. So this singleton design pattern is useful when you want to have like this single point of control of something, right? for people that have are really like Tolu now. There's a senior software engineer. Uh, Probably understands this configuration manager, or you're trying to connect to a database. So to avoid always doing that repeatedly, right? We could always just do it once at one entry point and reuse it all over the system. So you don't end up with confusion or unnecessary copies. So it's a way to like keep things organized and like make sure everything works smoothly. So let's take a quick look at, I think there's an example that I dropped. Um, like I explained earlier, Java is my first job, so I had to like drop the example using Java. Again, guys, please just drop a thumbs up. I want to be sure that I'm actually communicating and I've not lost anyone on the way. Yeah. So this actually means that like people are listening. So let's quickly touch on this implementation of Java. So the first thing that is happening here is you're creating like this singleton class called single object. So in this single object class, it kind of like ensures that only one instance of the class can be initiated. And how does it do this? So if you look at this, it has a variable called instance. So this instance initiates or instantiates, an object of this class using the new keyword. So after doing that, you're making your no act constructor, which is the single object, private, and nobody can access it from outside. And then you're creating a you're creating a method called get instance. This get instance is the method that now does the instantiation for you. This is the method that you can call wherever in your system. Once you call get instance, you know that what it's doing is it's creating a copy of the single object class. So you don't have to repeatedly be doing new single object anytime you want to instantiate single objects. Let's say you have what example can I give? Okay, you have a class called student, and you also have a class called school, and another class called um, classroom. So obviously, you need students in the school and in the classroom. So instead of doing instantiating students using the student equals to new student in the school and also in the classroom, making use of the get instance function does this, eliminates the usage of always using the new keyword. So this is what this implementation is actually doing. The next design pattern that we'll be covering is the factory pattern. I like giving instances when I'm explaining. So let me give you another instance. Imagine you're at the food restaurant, a restaurant, right? And the chef in the kitchen knows how to make all sorts of rice, jollof rice, fried rice, fada rice, even the normal white rice and stew, right? And you're just a customer. You don't need to worry about how exactly this rice is made, right? All you need to do is you get the menu, you tell the waiter what kind of rice do you want, like you want, and then the chef takes care of it for you. That's it. That's factory pattern in layman terms. But in software engineering, the factory design pattern is like that chef. It's a way to create objects without like worrying too much. I like this comment, listening attentively. Guys, can we please raise thumbs up? I don't know why I kind of feel like I'm talking to myself. Thumbs up or drop messages that you're actually following. Why is the only Taiwo that is dropping the thumbs up? Let's go on. Sorry. I was explaining the factory patterns. So in software engineering, factory design pattern is like that chef that I just explained. It's a way to like create objects without like worrying too much about the details of how they are created. So instead of like directly making objects using their constructors, constructors are like functions or methods that you use to instantiate the class. These are constructors. So instead of making objects using their constructors, you use a factory to create them for you. So what is a factory? To break it down again, it's like in the real world sense, you have a shoe factory. What does a shoe factory do? It creates shoe basically. So a factory is like a blueprint or um, a specialized method that is responsible for just creating objects. So just like again, like I gave an instance, just like a real world factory produces like products or yeah, products generally, right? A software factory creates instances of classes or objects basically. So it's a way to like centralize and manage the creation process, making it easier to like create different types of objects in a consistent and controlled manner. Again, it's just like you're ordering food from a menu. You tell the factory what kind of object you need, and it handles the creation process, right? So this factory pattern is like handy when you have different types of objects that needs to be created in a consistent way, right? But you also like have to keep the creation process separate from the rest of your code. So let's touch on the example. If this code that I'm sharing is turning your eyes, can you raise a thumbs up? I want to know the people that okay. uh, Wow. Tolu, why is the code turning
I
your
mean, but I just joined to be fair, so keep going. Maybe I'll catch up. And I hate Java for everything, so maybe I'll relate it to stuff I know. So maybe don't take my example.
okay, that's fine. Okay, let me just give a breakdown of what this code is doing exactly.
Taiwo said you only write JavaScript and Python.
Well, I get where you're coming from. You know, from an OOP background, so same here. No worries. I'll give you a breakdown of the code. So first of all, in the code, you're seeing like this interface called shape. Shape is an interface with a function or a method called draw, right? So this interface serves as a blueprint for various shape implementation. For example, in the code, you can see rectangle, square, and circle. So all of these classes, they all implement the shape interface. So thereby, when I mean implement, I mean they are getting the draw method right from the interface called shape, but they are specifying how exactly they want their own shape to be drawn. Right? Normal shape. But then you know how you draw rectangle, square, and circle is different. Right? So this is exactly what these different classes are doing. They're getting the draw method from the shape interface, but they're also specifying how they want like the shape to be drawn. So the next thing you can see is the shape factory Java class, the shape factory Java class. Right? What exactly this shape factory does is it acts as a factory, like I explained initially. So what it does is it creates objects based on the input provided. So it has a method called getShape. This getShape takes a parameter. Should I use the word? Yeah, parameter called shape type, right? So once it gets this shape type parameter, it returns an instance of the corresponding shape type. So let's say you pass a shape type called circle, it returns an instance of the circle class, right? Which is like a circle object. If you pass the rectangle as the shape type, it returns a rectangle object. So similar to the square. So using I think the last class on this is the factory pattern demo. So what this actually does is to actually demonstrate how the shape factory creates different shapes. So this is actually like where you actually call the shape factory class inside the demo, just to demo what exactly the shape factory is doing, right? So basically, what this implementation does is to give a broader explanation on what factory design pattern. So like I explained before, a factory design pattern is used to centralize and manage creation process, right? So you can tell, like the restaurant example I gave, you can tell a chef whatever you want. I want ofada rice or I want jollof rice. You don't care about how exactly it's happening, but you know that once you place the order for that ofada rice, you're getting it. So that's exactly what this shape factory does. Once you call the get shape and you're passing in that shape type, be it rectangle or square or circle, it gives you an instance based on that type. I almost said somebody shout hallelujah, but I hope you guys are listening. Thumbs up, please. So let's go to the next one. Next one is the observer pattern. I think before I go on, in case you have like questions, based on my explanation, so you don't forget, you could like always write it down somewhere, or even on the chat. I could go through it later on and give answers to the questions. But let's proceed to the observer pattern. Again, I want to give an instance. For this observer pattern, let's assume that we have a game, right? I don't play games, so I can't give an instance like that. But let's say you have a game with like different characters. When one character A, you have character A and character B. So if character A's health changes, or maybe character A even dies in the game, the observer pattern like lets other parts of the game know it without it affecting the other part. So let me take it again. You have a game. Maybe I should use Code Wars as example. And you have like two soldiers, soldier A or soldier B. Soldier A dies. So what the observer pattern it does is it lets the other parts, which is like the soldier B, know about it without like constantly checking on soldier A, right? Or without it affecting soldier B. So this way your program stays efficient and organized. So the fact that something is wrong with a particular part doesn't mean that the other parts gets affected. So this ensures that everything in your application reacts to changes as needed. So in software, the observer pattern like works similarly to um, when you're subscribing to a weather update service. So when you check the weather for today, or is it going to rain today? Is it sunny today? Is it cloudy? So every time the weather changes, you get a notification. You don't have to constantly go to maybe the weather application to check, or what's the status? Is the weather going to change? Has the weather changed? You automatically get the notification. That's exactly what the observer pattern does. So it makes sure that one part of your program gets notified automatically when something changes in another part. Basically, that's what the observer pattern does. So let's quickly look at an example. Okay. Um, let's break this example down. It looks confusing, but in the long run, you just realize that it's just text, text, text everywhere. So the first class that we're seeing here is the subject class. So initially, first of all, you create the subject class with a property called observers, which is private. Observers, as um, types of list of observer, right? And also has this variable called state. State, right? This list of observers is like a list to hold the observers that are like interested in the changes of this subject class, right? The get state obviously returns like the current state. Set state sets the state. I don't know if anyone is familiar with. I don't know if it's just OOP, but yeah, OOP, the getters and setters, right? So this subject class also have a function called attach. Basically, what this attach does in this code is it adds an observer to the list of observers. So now I'm just saying subject and observer, subject and observer. So let's see it like this. Um, the observer is that part of your program that gets notified, right? The subject is the part that something happens to or something changed. So for the weather is like the subject. I am the observer. So I want to get notified when the weather changes. So that's the observer and the subject. So as I was explaining, the attach adds an observer to like the list of observers that are like interested, that wants to be notified when a change occurs. Right? The next class we're creating here is the observer class. So what the observer class does is the observer class is an abstract class. So what it does is it has a field called subject and a function update. So basically the observer class holds like a reference to the subject it observes and declares like an abstract update since it's an abstract class. And then after creating the observer, which is an abstract class, you have three different classes: the binary observer, the octal observer, and the hexal observer. These classes extend from this observer. Extension you is basically inheritance in software engineering term. It's basically you trying to like get fields, functions, or materials that you need from that particular class, from the superclass. So these binary observers and the other observers are extending from observers. So indirectly, they have access to the subject field and the update function from the observer. So basically, what they are doing is they can either decide to, most likely, they're overriding the function that they got from the observer, the update. So they are updating it. Let me use the term updating. They're updating it to show that for the binary observer, it prints it prints like the states, the subject state in binary format in name and times. The octal observer prints it in octal string, the hexa to hex string, right? So these three different classes are doing three different things. Again, I'm going to use the restaurant instance. The observer is the observer is the chef in this case, and then these three classes are like the types of rice that you want. Basically, using the instance that I created. So this, where's the class that you call it in the observer pattern demo? Sorry, sorry. In the observer pattern demo, you're basically just creating an instance of the subject and the concrete observer class, which is the observer class that you created, right? And then what you do is you register each observer with the subject and then change the state of the subject. So once you change the state of a subject, immediately observers get notified depending on the instance they are calling, either the binary or the octal or the hexa. If you call the octal instance, you immediately get notified in a octal string. So basically, that's what the observer method does. Kyle, thanks for the reference on the chat. Um, so before we go to the last design pattern, um, can we just ensure that we're following? Maybe drop thumbs up or a message in the chat. So I say this just to make sure that people are actually understanding what I'm saying and people are actually following it. Okay, so let's go to the last design pattern, which is the MVC. So this MVC pattern is quite popular. I mean, it's very popular, not quite popular. I'm pretty sure if you ask anybody what is MVC, they can easily tell you that it's model, view, and controller. So let's give an instance again for this NVC pattern. Let's think of a restaurant, a kitchen in a restaurant, right? Where all cooking's food preparation happens. The chefs are the models, which is the M, right? The chefs handles the ingredients, the recipes, the cooking techniques that you need to make food, right? They make the foods that is delicious, and ready to be served. This is the work of the model in real life sense. The view, let's imagine the chef standing in front of the kitchen, right? Dining area, right? Where you actually can sit take orders from the customers and then communicate with the kitchen. Oh, this is what this person wants. This person wants fried rice. This person wants chicken. This person wants chicken.